So this is a smooth pulley. Inextensible light string goes over the pulley, right? An object of 4 kilogram is connected to one end of the string, right? And another object of 6 kilogram is connected to the other end of the string, right? The system is released at rest and there will be an acceleration, right? Right. So please write. You can use any book as you wish, but linear motion book is better. Please write. Consider the following system. Consider the following system. Consider following system contains a smooth pulley and two masses. Consider the following system contains a smooth pulley and two masses. Full stop. The string is light and inextensible. The string is light and inextensible. Right. Draw this figure. We are going to find the tension in the string and the acceleration of the system. A student said it's difficult for him, so I'm going to help. So there may be some students who think still this kind of questions difficult. It's better to revise, right? And I'm really happy when a student ask me to discuss, especially when a student tell me that a section is difficult and asking me to discuss a question to revise it. I'm very happy with that kind of students. So please draw this figure here quick. Right. So we want to find the tension in the string as well as we want to find the accelerations. So we should mark the forces acting on the objects. The weight of 4 kg object is acting downward. Similarly, weight of 6 kg object acting upward. The tension in the string acting upward and tension in the the other end of the string also acting in the upward direction. The same string, it does not have a mass. Light string means the string does not have a mass. Therefore, tension forces will be the same. So if the tension here is capital T Newton, if the tension here is capital T Newton, tension at this end is also capital T Newton. Please mark the forces there. But weight forces are different. The gravitation attraction force acting on 4 kg object, let me take it as M1G Newton. That is the gravitation attraction force acting on the 4 kg object, which is known as weight of the object. The gravitation attraction force acting on the 6 kg object is M2G Newton. Again, it's normally known as weight of the object. So you should identify that 6 kg object has more weight. 6 kg object has more weight. Therefore, system will be rotated into this direction. 6 kg object will be moved downward and 4 kg object will be moved upward. As 6 kg object has more weight, it will be moved downward. When it is moving downward, it pulls the string downward. Therefore, 4 kg object is moving up. Right. So let me mark the acceleration as simple A meter per square seconds. Right. So acceleration of simple 6 kg object is simple A meter per square seconds vertically downward. So as 6 kg and 4 kg objects are connected together by a string, when 6 kg object moving with a certain acceleration, 4 kg object should have the same acceleration, but it will be upward. So let me mark the acceleration of 4 kg object also simple A meter per square seconds. So I have marked the two accelerations of the two objects and I have marked the tensions. Start there, mark them all. Right. Can somebody type the question and send to Zoom chat, because there are some students who joined to the class just now. It will be a big help if you type the example and send it to the Zoom chat so I can share it with all the students. That will be a big help. You may write this in linear motion note. If you want, you can write a heading as Newton's laws, but do not write pulley systems. It's not a good heading because here just we use Newton's laws, not more than anything that. Okay, dear. Light string means massless string. If the string does not have a mass, the tension forces at any point in the string will be the same. Right. Now the process is very simple. We apply F equals ma equation. Right. We apply F equals ma equation only to 4 kg object. Only to 4 kg object. Right. And we should indicate the direction that we apply the equation. So 4 kg object is moving up. Therefore, I apply F equals ma equation vertically upward. I apply F equals ma equation vertically upward. So look at board. Please don't write anything. Just look at board. There are two forces acting on the 4 kg object. One of the forces acting upward, the other force acting downward. Therefore, the total upward force is capital T minus m1g. Total upward force, or you can say resultant upward force, that is capital T minus m1g. This is the total upward force or the resultant upward force. Equals mass is 4, acceleration is simple a. We can write one more step. T minus m1 is given as 4 kilogram. The value of g is 10 equals 4 into a. 4 into a. Okay. Okay, dear. Right. Now look at board, dear. Look at board. So here capital T minus 4 into 10 is 40 equals 4 times a, 4a. So now I'm not going to simplify anything further. I just keep as it is, and I'll mark this as my first equation. Write the first equation here. We have obtained equation number 1 by applying F equals ma to the 4 kg object vertically upward. Write them all here. Right, let's apply the same equation to the 6 kg object, right? So we have, let's apply F equals ma only to 6 kg object. We apply F equals ma only to 6 kg object, but 6 kg object is moving downward. Therefore, we should apply the equation vertically downward, right? So then we can apply. So the downward force is M2G, upward force is capital T. Therefore, the total downward force is M2G minus capital T equals mass is 6. Acceleration, simple acceleration is simple, we don't know. So M2 is 6 into G is 10 minus capital T equals 6 into A is 6A, right? 6 into 10 is 60 minus capital T equals 6A. So I'm not going to simplify this any further. I'll mark this as my equation number 2. Just write this also, dear. Right now, the process is very simple. Just add 1 and 2 equations. We can obtain the acceleration, right? The only thing that we want to do, let's add equation number 1 and equation number 2, right? So then we will obtain equation number 1. It tells T minus 40. Equation number 2, that is 60 minus capital T, equals equation number 1, that is 4A. Equation number 2, that is 6A. That is 6A, right? So you should understand that this capital T and this plus T and this minus T cancelled out. Minus T, this plus T and minus T cancelled out. So what are the remaining terms, dear? Remaining terms will be, here we have minus 40. We will have minus 40 here and plus 60 will be there. 4A plus 6A is 10A. 4A plus 6A is 10A. Right? Now, the easiest way to simplify is, let me write the positive number first. The positive number is 6. The negative number, let me write the negative number next. The negative number is 40 equals 10A. Equals 10A. Now 60 minus 40. 60 minus 40 is 20. 60 minus 40 is 20. So 20 equals 10A. Now you see, this 0 and this 0 cancelled out. You will get A equals to. Finally, you will obtain that A equals to, unit is meter per square seconds. Right. Please raise your hand up in Zoom chat if you obtain the answer here. Who has obtained this answer? Acceleration is 2. Anybody in the class? Okay, very good. I'm so happy. Please complete the note. Right. What should we do to find the tension force there? Two different objects, two different masses, two different motions. Therefore, the equations will also be different. Got it? So when we apply F equals ma to the 4 kg object, it's moving up. So upward force is T, downward force is M1G. Therefore, the total force will be T minus M1G. T minus M1G. We don't use the term total force, we say resultant force. But once you consider 6 kg object, it's moving downward because it has larger mass, larger weight, right? So downward force M2G, upward force capital T. Therefore, the total downward force will be M2G minus capital D. M2G minus capital T. So which is known as the resultant force. Okay, dear. Now use equation number 1 and find the tension, dear. Use equation number 1 and find the tension. You will try. So equation number 1 tells us, right? T minus 40 equals 4A. That's what said by equation number 1. So I'll do something like this. I'll keep capital T here. I don't do anything to 4A, but I'll take minus 40 to the other side. This minus 40 goes to the other side as plus 40. Minus 40 goes to the other side as plus 40, right? So then acceleration, we have found it as 2. 4 times 2 plus 40. 4 times 2 is 8. 4 times 2 is 8, right? Plus 40, 40 plus 8, 48. Therefore, the tension force in the spring is 48 Newton. So there will be many questions from Newton's laws of motion, including pulleys and many other things. You should try them first. I'll discuss all of them in our tutorial discussion class. Paper plus tutorial discussion class is there. I'll discuss all the questions, but you should try them before I discuss them. Otherwise, it's useless. Who got the answer of capital T correctly, dear? Who got this answer earlier than me? Anybody in the class? I think time is more than enough for you to write all the things. But if you need any more time, please take a screenshot. I'm going to erase all the things, and I'll discuss 2 more questions for Newton's laws of motion. I think it's very good to revise the things like this. We must be very much grateful to the student who asked me to discuss some Newton's laws of motion questions. I think it will be a good help. Right. So please take a screenshot. I'm going to discuss another question. Right. Please write example number 2. Example number 2. Example number 2. Two objects are connected to the ends of a light inextensible string. Two objects are connected to a light inextensible string. Two objects are connected to the ends of a light inextensible string. Two objects are connected to the ends of a light inextensible string. To the ends of a light inextensible string. The string goes over two smooth pulleys. The string goes over two smooth pulleys as shown in the following figure. As shown in the following figure. Right. Can somebody unmute the mic and read? As shown in the following figure. Full stop. Find the tension in the string and acceleration of the system. Find the tension in the string and the acceleration of the system. Find the tension in the string and the acceleration of the system. Find the tension in the string and the acceleration of the system. Right. Somebody please unmute the mic and read the example number 2. Somebody please read example number 2.
Of a light inextensible string. The string goes over two smooth pulleys as shown in the following figure. Find the tension in the string and the acceleration of the system.
Right. Thank you, dear. So let me draw the figure. Please draw the figure with me, dear. So this is the table. There are two metal supports. There are two pulleys. This is the string, and these are the two objects. Draw the figure with me, dear. Please don't wait. So I have marked the weights of the objects, right? And tension forces in the string. Right? So this should be a smooth curve, but it's somewhat difficult for me to draw, right? It's not easy for me to draw, but I think you are better artists than me. Okay, let's complete the figure. So weight of the first object acting downward as M1G, the tension force acting upward as capital D. Weight of the second object acting downward as M2G, right? The tension force of the second object acting on the other end of the string acting upward. So 10 kg object is heavier, therefore 10 kg object will be moved downward. 6 kg object is less mass, so it will be moved up. But as both objects are connected by a string, both should have the same acceleration as simple A. The only difference is one is moving up, the other one is moving down. Draw the figure, and can you find the tension in the string and the acceleration of the system without my help, dear? You will try. So we want to do the same thing here. We should apply F equals MA to 6 kg object, F equals MA to 10 kg object. So even we have 100 pulleys, we should always want to apply F equals MA. That is not more than that. Therefore, it is useless to discuss questions like this. System with 1 pulley, a system with 2 pulleys, a system with 3 pulleys, a system with 4 pulleys. So that is completely useless. The only thing is you should know how to apply F equals MA. Not more than anything that. So F equals MA only to 6 kg object, right? So I apply this equation upward because object is moving up. Upward force is T, downward force is M1G. Therefore, the total upward force is T minus M1G. I'm applying F equals MA vertically upward. I'm applying F equals MA equation to 6 kg object vertically upward, right? The total upward force is T minus M1G. The mass is M1. Acceleration is simple A. We don't know what the acceleration is. T minus M1 is 6 kilogram. G is 10 equals mass is 6. Acceleration is A. So we will obtain that T minus 6 into 10 is 60 equals 6 into A is 60. So let me take this as my equation number 1. Write them all there. Write them all. You must clearly indicate the direction of the equation. So I apply this equation vertically upward. Okay. If a pulley is said to be rough, then there should be friction. But in advanced level, we have smooth pulleys. But I would like to discuss questions with rough pulleys also in our tutorial and paper discussion class, but not in the theory class. It will be a good experience if we discuss some questions with rough pulleys, but not in the theory class because then bio students will leave the class. But paper class, it's okay. Let us apply the same equation to the 10 kg object. Let me apply F equals MA only to 10 kg object. 10 kg object. But I have to apply the equation downward because 10 kg is heavier, it's moving downward. The downward force is M2G, upward force is capital T. Therefore, the total downward force is M2G minus capital T. Equal mass is M2, acceleration is simple A. That's what we want to find. M2 is 10, G is also 10 minus capital T equals mass M2. M2 is 10, acceleration is simple A. 10 into 10 is 100 minus 100 minus capital T equals 10A. So let me take this as my second equation. As usual, just add 1 and 2 equations together. Then you can find the acceleration. Start there. Right. Let's add the two equations together. Right. Equation 1 plus equation 2. So then we will obtain equation 1 tells us t minus 60. Equation 1 tells us t minus 60. Equation 2, that is 100 minus capital T. 100 minus capital T. Clear? Equals 6a plus 10a. Got it there? So now you see this plus t and minus t cancelled out. This plus t and minus t cancelled out. Then what are the remaining terms there? The remaining terms here we will have minus 60 and we have plus 100 equals 6a plus 10a 16a. 6a plus 10a 16a. Right? So minus 60 is there, plus 100 is there. So the next thing is I'll write a positive number first. Positive number is 100. I'll write 100 first. Negative number next. That is 60. Equals 16a. 16 times a. So 100 minus 60. That is 40. 100 minus 60 is 40. Right. So we will get 40 equals 16a. Now I can take 16 to the other side. I can take 16 to the other side. 40 divided by 16 equals a. So 40 divided by 4 is we can divide both numbers by 4. So then simple a equals 40 divided by 4 is 10. 16 divided by 4 is 4. Am I right? So 10 divided by 4 means 2.5. Am I right there? Is the acceleration 2.5 meter per square seconds? Please check whether you have given the units also. Is this correct, Lamai? Who
Yes,
got this
sir.
answer? 2.5 meter per square second is the acceleration. Is it correct, Lamai? Please raise your hand up if you got the acceleration as 2.5. Okay, very good. I'm so happy. Right. How do you find the tension in the string here? To find the tension in the string, we can use equation number 1. Let's use equation number 1 and find the tension. From equation number 1, right? Equation number 1 tells us capital T minus 60 equals 6a. So capital T equals 6A minus 60 come to this side as positive 60. Minus 60 come to this side as positive 60. So this is 6 into acceleration. We have found acceleration as 2.5. Or you can write 10 over 4 as you wish. Right? So I'll write 2.5 plus 60. That is 60. Right? So let me multiply it. 6 times 5 is 33 remaining. 6 times 2, 12 plus 3, 15. One decimal point should be removed. Am I right? 6 times 5 is 30. I have written 0. For this decimal point, I should put a decimal point. 3 remaining. 6 times 2, 12. Plus that 3, 15. Correct. And this is 60. So then 15 plus 60. 15 plus 60 means 75. 75. Who got this answer here? Tension in the string is 75 Newton. Who got this answer, Lamai? Please raise your hand up if you got this answer. Okay, very good. Nice. Right. I'll discuss one more example. Example number 3. These things are very interesting questions for Newton's laws of motion, but never treat the questions by counting the number of pulleys. That is useless. You should be able to see these questions as Newton's laws of motion questions. Right. So, write example number 3. Example number 3. 3 objects are connected together. Example number 3. 3 objects are connected together by 2 TWO, by 2 light inextensible strings. 3 objects are connected together by 2 light inextensible strings. By 2 light inextensible strings. First stop. The two strings go over. The two strings go over 2 smooth pulleys. 2 strings go over 2 smooth pulleys. 2 strings go over 2 smooth pulleys. 2 smooth pulleys. full stop. The system starts to move at rest, full stop and continue. The system starts to move at rest as shown in the following figure. The system starts to move at rest as shown in the following figure. The system starts to move at rest as shown in the following figure. Full stop. Full stop. Find the acceleration of the system and find the acceleration of the system and the tensions in the strings. Find the accelerations, find the acceleration of the system and tensions in the strings. Find the acceleration of the system and tensions in the string, in the strings, s plural, strings plural. Find the tensions in the strings. Right. I'll draw the figure, but before that, somebody unmute the mic and read example number 3. That will be a very big help for the students who have not written the example yet. So somebody unmute the mic and read the example loudly.
3 objects are connected together by 2 light inextensible strings. The 2 strings go over 2 smooth pulleys. The system starts to move at rest as shown in the following figure. Find the acceleration of the system and tensions in the strings.
Jazakallah Baba. Thank you. Now let me draw the system. Now I slightly change. I'm using the same example. The only thing I do is, look at board. I connect another mass into the middle, like this. I connect a mass to the middle like this. That's the only thing I do. Now there are 2 strings. This is the string number 1. This is the string number 2. Or you can take this is string number 1 and this is string number 2. Can you understand here? So there are 2 strings and 3 masses. Got it? 2 strings and 3 masses. Start there. Draw the figure. Draw the figure and give a try to find the tensions. And listen there. Wait. One more thing. One more important thing. Now there are 2 different strings. 2 strings. Therefore, tension forces will not be capital T, capital T. This will be T1 and this will be T2. Right? So as there are 2 different pieces of strings, the tension forces will be T1 and T2. Tension force of this string at this end is T2. Tension force of the same string, as it is a light string, tension force of the same string at the other end will be T2. T2 Newton is the tension force in both ends of the second piece of string. And T1 is the tension force in the both ends of the string number 1. T1 Newton and T2 Newton. Draw the figure and try to find the acceleration of the system and the tension forces T1 and T2. If you have any further doubt, you can unmute the mic and ask or send me a message to Zoom chat. I'm very happy when students ask questions. Draw the figure. Start. The mass of the middle object is 2 kilograms. I forgot to give you. Mass of the middle object is 2 kilograms. Now everything are provided. And there are no friction forces. Start. Send your answers to my Zoom chat. as the 10 kilogram object is much heavier, all the objects move to the side of the 10 kg object. As all the three objects are connected together, all of them will have the same acceleration. Therefore, acceleration of the middle object will also be simple a meter per square seconds. All the three objects will have the same acceleration because all of them are connected together. Start. I forgot to mark the directions of the tension forces. The tension forces in the string are upward and this tension force is into this direction, right? So mark the tension forces properly, right? I have explained many times how to mark the tension forces in a string. But if you think that you want me to explain how to mark the directions of the tension forces, you can send me a message Zoom chat. But I already explained it many times. Until you do the question, I can give you a help there. So if you consider this 10 kg object, M2G force acting downward. So let's say if the object is at rest, then what should be the direction of the tension force? So I know that there are very extremely good students. I'm not giving that help for the such genius students. Until genius try for the question, For the normal students, let me give this help there. I think you will not get angry with me. Listen there. Weight means the gravitation attraction force, right? So gravitation attraction force, that is M2G, acting downward, okay? So if you connect a string, isn't it? If you connect a string, right? And if you keep this object at rest, what should be the direction of the force given by the string there? Upward or downward? M2G Newton force pull this object downward. You connect a string and you try to keep the object at rest. So what should be the direction of the force given by the string there? Upward or downward? Yes, it should be upward. That's why I have marked the tension force T2 upward. That's why I have marked the tension force T2 upward. Is it clear? Is it clear, or may I again explain? If you want to explain this part of tension force, please raise your hand up. So I'll explain this again. If you want me to explain this T2 direction, please raise your hand up. Right. Now, by considering this 10 kg object, I can apply F equals MA only to 10 kg object. Right. I can apply F equals MA only to 10 kg object. Right. So M2G force is large because weight of the gravitation attraction force is larger. Therefore, object will be moved downward. So I apply F equals MA vertically downward. I apply F equals MA equation vertically downward because weight of the object is larger. That's the reason. Right. Now, what is the downward force there? The downward force is M2G. Upward force capital T. Therefore, total downward force is M2G minus T. One force is acting downward, the other force acting upward. Therefore, the total downward force is M2G minus capital T. Mass of the object is 10. Acceleration is simple A. And this is our equation number 1. This is our equation number 1. Right. So I can write it. I can keep it here. Now it's very clear. Right. So this is our equation number 1. Right. This is our equation number 1. Right. And I should indicate the direction also. What has happened, it is Zoom did not recognize it as its own thing, right? Whatever. Right. Now, okay. Right. So we have applied F equals MA only to 10 kg object. So I'm going to explain the directions of the tension forces. So I have explained direction of this one. It's very clear. If you consider the string, right? When the string, this 2 kg object is moved to the right hand side. This 2 kg object should be moved to the right hand side. Therefore, what should be the direction of the force given by the string there? 2 kg, 10 kg object is heavier. Therefore, it is moving downward. When it is moving downward, the string pulls the 2 kg object. So therefore, what should be the direction of the T2 Newton force given by the string to the 2 kg object? Into the right hand side or into the left hand side? Lamai? Into the right hand side. Therefore, T2 acting on the 2 kg object is into right hand side. When this object is going to move to this direction, because of the weight of 6 kg object, it pulls the string to that direction. M2G, M1G, that is the weight of 6 kg object. It pulls the first string downward. As it as it pulls the first string downward, T1 tension force should be into left hand side. Is it clear, or may I again explain? The 6 kg object, the gravitation attraction force acting on 6 kg object pulls the string downward. Therefore, T1 tension force should be into the other direction, into left hand side. Is it clear or not? Lamai? Would like if I explain the direction of this T1 force again? Please raise your hand up if you want to explain this again. Right, it's clear for all. Very good. Now, if you consider this 2 kg object, but if it is still not clear, send a message Zoom chat. So, if you consider this 2 kg object, only two forces are acting on it, T1 and T2. T2 is larger. Even T1 is acting to this direction, T2 is larger. Therefore, 2 kg object will be moved to this direction. So, if I apply F equals ma only to 2 kg object, the direction is into a right hand side, right? The direction, it is moving into the right hand side. So I should apply F equals ma into the right hand side. Aswan asks a very interesting question. 10 kg object pulls it. Whatever the force given by the 10 kg object, the gravity gives another force to 6 kg object. M1G always pull the string to this direction. Can you understand? Whatever the force given by the 10 kg object, M1G, gravitation attraction force acting on the 6 kg object, pulls this string to this direction. Therefore, T1 should be into that direction, right? But the force given by 10 kg is larger. Therefore, object will be moved into right hand side. Got it? Is it clear here? Or may I again explain? The same string have the same tension forces. If the string does not have a mass, ends of the string will have the same tension force. I have explained it at the very beginning of Newton's laws of motion. So if you want to explain the reason for this to be T2 and this to be T2, then I had to reteach Newton's laws of motion. But even I am ready to reteach. If so, please send a message to me. Right. So now I apply F equals ma to 2 kg object, T2 acting to right hand side, T1 acting left hand side. As object is moving to right hand side, the total force acting on the object is T2 minus T1 is the total force acting on 2 kg object into the right hand side. Mass is 2, acceleration is simple A. We don't know any of these things. So let me mark it as equation number 2. Right? So we have applied F equals ma to the 2 kg object and to the 6 kg of 10 kg object, and I should apply F equals ma to now 6 kg object. Now a 6 kg object is it's very clear, right? Gravity pulls the object downward, but 6 kg object is moving up. To move 6 kg object upward, the string should give an upward force. That's why T1 is upward. Correct? 6 kg object is moving up. To move it up, the force given by the string T1 should be acting upward. That's why T1 is upward. So I have explained. So I have explained even the directions. Now, the next thing that I should do is I should apply F equals ma only to 6 kg object. 6 kg object. Right? The force acting upward is T1. I'm applying the equation upward. The downward force is M1G equals mass of the 6 kg object is 6. Acceleration is A. Still, I didn't receive any answers, dear. You must have obtained the answers earlier than me, right? Please do the question and send me your answers from chat. I'm waiting. So this is T1 minus M1 is 6, G is 10, equals 6 into A is 6A. So T1 minus 6 into 10 is 60 equals 6A. So let me take this as equation number 3. Right? If you have already obtained the answers, please send your answers Zoom chat there. I'll be very happy if you send answers to me. Right? Do not forget to indicate direction whenever you apply an equation. Please indicate the direction of the equation. It's a must. Some students had sent me the answers. Acceleration is said to be 20 divided by 7. Is it correct there? 20 divided by 7 or 2.22 meter per square seconds. Acceleration is said to be 20 over 7
9, sir.
or 2.22 meter per square seconds. What about the tension there? What about the tension? Tension T1 and tension T2.
T1 equals 220 over 3.
220 over 6 or 7. Here, T1 equals 220 over 6 or 220 over 7. I didn't hear you answer properly.
220 over 3.
220 over 3. Check clear. Please send your answers Zoom chat, then it is easy. Everybody please send your answers to the Zoom chat, T1, T2 and acceleration. The easiest way to simplify this is, right? The easiest method to simplify this is adding the 3 equations together. Just add 1, 2, 3 equations. Add equation number 1, equation number 2, and equation number 3 together. Equation number 1, T2 minus T1. No, equation number 1, I forget some. Equation number 2 is equation number 1 is M2G minus M2G minus T2 dear. Sorry, there's a mistake. This should be equation number 1. This should be T2, not only T. T2. I forgot it. T2. M2G minus T2. M2G acting downward, T2 acting upward. So M2G minus T2 is equation number 1. This is equation number 1. Plus equation number 2. Equation number 2. Plus equation number 3. That is, equation number 3 is T1 minus 60. T1 minus 60. Check whether I have written the 3 equations properly. Equation number 1 means M2G minus T2. Equation number 2, T2 minus T1. Equation number 3, T1 minus 60. T1 minus 60. Then add the other terms. What are the other terms here? 10A from equation number 1. 2A from equation number 2. 2A from equation number 2 and 6A for 6A from equation number 3. Please check them all here. Please check whether I have written them all properly. Now you see the beauty. This minus T2 and this plus T2 cancelled out. Minus T2 and plus T2 cancelled out. Minus T1 and plus T1 cancelled out. So it means all the T1 and T2 terms cancelled out. The remaining terms will be M2G minus 60. This one here. This 60 will be there. That's all. Equals 10A plus 2A plus 6A, right? We know the value of M2. M2 is 2 kilograms. So M2G means M2 is 2 kilograms. G is 10 minus 60. Is there any mistake there?
So M2 is 10 kilogram.
M2, sorry. M2 is 10 kilogram, not 6 kilogram. M2 is 10 kilogram. That's the mistake. 10 kilogram equals 10A plus 2A, 12A, 12A plus 6A, 18A. Am I right here? 10 plus 2, 12, 12 plus 6, yes, 18. 10 into 10, 100.
Yes, sir.
100 minus 60. 10 into 10 is 100. 100 minus 60 is 40. Am I right? 100 minus 60 is 40. 40 equals 18A. Check whether I'm okay up to this point here. 40 equals 18A. So I can take 18 to the other side. I can take 80 into the other side. So it will be 40 divided by 18 equals simple. So A equals 40 divided by 2 is 20. 18 divided by 2 is 9. Am I right? 40 divided by 2 is 20. 18 divided by 2 is 9. So is it 20 over 9 meter per square seconds?
Yes, sir.
Yes, sir.
So we have found the acceleration. Right? How do you find the tension, dear? Then we have found the acceleration. What should we do to find the tension? Lamoy, tensions T1, T2. T1 can be found by equation number 3. T2 can be found by equation number 1. Simple, right? So from equation number 3, we can find the tension. Tension T1. T1 minus equation number 3. T1 minus 60 equals 6A. Right? So T1 equals 6A minus 60 comes to this side dash plus 60. Minus 60 comes to the other side dash plus 60. So 6A What is ADL? We have found acceleration as 20 over 9. We have found the acceleration as 20 over 9. 6A means 6 into 20 over 9 plus 60. 60. Now you see, it's very simple. Very simple. 6 divided by 3 is 2 into 20. 9 divided by 3 is 3. 9 divided by 3 is 3. I'll keep it somewhere here. Then it's okay, right? 6 divided by 3 is 2. 9 divided by 3 is 3. Okay. Plus 60. Okay. I'll write few more steps for the tension force T1. 20 times 2, 40 over 3. 40 over 3 plus 60. So next step, let me take 3 as the common denominator. In the next step, let me take 3 as the common denominator. So nothing will happen to 40, right? Nothing will happen to 40. But once we take 3 as the common denominator, this 60 should be multiplied by 3. That's the rule. This is how we take the common denominator. Get it? When we take 3 as the common denominator, 40 divided by 3 remains unchanged. 40 and 3 remains unchanged. But 60, that should be multiplied by 3. So finally, 40 plus 60 times 3, 180. Divided by 140. 40 plus 180 means 220. Yeah, I think the student told me this answer, 220 divided by 3. For my question, it's enough to keep the answer as fractions, but in the examination, you must divide them. For my question, it's okay to keep the answer as 220 divided by 3 Newton. Who got this answer? Lamai, who got this answer? Please raise your hand up if you have obtained this answer. Lamai, for the rest of the calculations, I have to erase equation number 1, equation number 3, and equation number 2. So if you want any more time to write 1, 2, 3 equations, please take a screenshot. I am going to erase this side. I'm going to erase this side because I need some space. Right. So I'll use equation number 1 to find the tension force. I use equation number 1 to find the tension force T2. I use equation number 1 to find the tension force T2. So I can write from equation number 1. Right. And I'm going to find the tension force. So this is equation number 1. Am I right, dear? I'll erase this one also, dear, because now I think time is more than enough for you to write this, the things that are written in brown color. So I'll erase that one also. We don't want that much of time. So otherwise I cannot manage this space. Now I use equation number 1 to obtain the answer for T1, T2. Right. So equation number 1 tells us M2G minus T2 equals 10E. Right. So M2 is 10, G is also 10, minus capital T2 equals 10. Acceleration, we have found the acceleration as 20 over 9, as I remember. Am I right there? Is it 20 over 9?
Yes, sir.
Yeah. Now you see this 10 and 9 cannot be simplified any further. So 10 times 10 is 100 minus capital T2 equals 10 into 20 is 200 over 9. 200 over 9. So the thing that I am going to do is I'll take T2 to the other side. I'll take T2 to the other side, 200 over 9 to the side of 100. So I'll interchange the terms. So it is 100, positive 200 over 9 come to this side as minus 200 over 9. Positive 200 over 9 come to this side as minus 200 over 9. And minus T2 goes the other side as positive T2. So as usual, let me take the common denominator as 9. So once we take common denominator as 9, nothing will happen to this 200. Because 200 over 9, 200 over 9, that will not be changed. So it means minus 200 over 9 will not be changed. But once we take 9 as the common denominator, this 100 should be multiplied by 9. This 100 should be multiplied by 9. So that's the rule that we should use to obtain a common denominator. Equals T2. So 100 into 9 is 900. 100 into 9 is 900 minus 200 over 9 equals T2. Okay, dear. So this is the method, dear. Right. So please do not forget to multiply 100 by 9 when you take 9 as the common denominator. So 900 minus 200 divided by 9. What is 900 minus 200? 900 minus 200 means 700. It means T2 equals 900 minus 200 means 700 divided by 9. The unit is Newton. Who got this answer? Samai, who got this answer? Please raise your hand up in the Zoom chat. I'll be very happy if you obtain the answer, dear. I'm happy when students are successful. I'll be very happy. That's why I'm asking to raise your hands up. Okay, very good, very good. I'm so happy. Nice, excellent. Almost all the students got the answer. Happy? Write down everything. if you have any doubts, send a message to the Zoom chat. And if you have written all these things, send a message Zoom chat saying done. Then I'll go to circular and rotational motion theory. Right? I want to go to circular and rotational motion theory. So if you have written them all, send a message to Zoom chat saying done. Right, almost all the students said that they have written, but even a single student is there who has not written these things. Please take a screenshot. I'm going to erase everything. If there's even a single student who has not written these things, please take a screenshot. Okay, so I'll erase. So in this question, they ask us to find the tensions and the accelerations. Right. So we have found the tension T2 as 700 over 9. Right. In this question, we have found the tension force as 700 over 9. And the tension force T1, we have found the tension force T1 as we found the tension force T1 as 220 over 3. These are the things that we have obtained in this question. We have found T1 and T2. And the next thing that they have asked us to find the acceleration. Right? By using the things that are written in brown color, we have obtained the acceleration. We have obtained the acceleration as 20 over 9. Please tell me whether I'm right here, whether these three answers correct. Please tell me whether these three answers are correct here, T1, T2, and accelerations.
Correct, sir.
Thank you, dear. Right. Please, you also write the three answers separately like this. Then it will be easy. So these are the answers. But in the exam, do not keep the answers as fractions. You should divide them. But it's easy to simplify when you keep the things as fractions. When you keep the numbers as fractions, it will be very easy for you to simplify, right? Than using decimal places, decimal numbers, right? So I would like if you take a screenshot of the final answer with the figure, right? So there are so many questions like this in our 600 questions Tute, which was given for mechanics, linear motion, kinematic section of mechanics lesson. Try to answer all the 600 questions before I discuss them in the tutorial discussion class. Right? There are 2 tutorial discussion classes. Both classes are free. Right? You can join to any of the tutorial discussion classes, and you can check your answers. Right? To join to tutorial discussion classes to check your answers, not to learn there, because you must do these answers. You must try these questions before I discuss. Right? So that's enough for Newton's laws of motion revision case. We just want to revise Newton's laws of motion today, but our main lesson is circular and rotational motion. So let's go to that lesson.